Undoubtedly, artificial intelligence is the most trending technology at present. Tech giants such as Tesla, Amazon, and Netflix implement AI techniques to derive useful insights from data and grow their business. Hi everyone, I'm Zulekha from Edureka, and today we'll be discussing all about artificial intelligence and how it can be implemented by using Python. Also, before we get started, make sure you subscribe to Edureka YouTube channel in order to stay updated about the most trending technologies. So let me begin by discussing today's agenda. I'm going to begin this session by walking you through a couple of reasons as to why we choose Python for artificial intelligence. Then we'll move on and look at the most important and the most popular Python packages which are specifically used for machine learning, deep learning, and artificial intelligence. After that, we'll finally introduce artificial intelligence, where we'll discuss to what led to the need of artificial intelligence. We'll also discuss what exactly artificial intelligence is, the different types of AI. After that, we'll discuss the difference between artificial intelligence, machine learning, and deep learning. Then we'll move on to the machine learning module, where I'll discuss with you what exactly machine learning is, the different types of machine learning problems, machine learning process, machine learning algorithms. And we'll end the machine learning module by implementing a small demo by using Python, right? Next, we look at the limitations of machine learning and what led to the introduction of deep learning. Here we'll understand what exactly deep learning is, how deep learning works, what are neural networks, perceptrons, and multi-layer perceptrons. We'll end the deep learning module by discussing a practical implementation with Python, right? After that, we'll move on to our last module, which is natural language processing. Here we'll discuss what exactly NLP is, where it is used, its applications, and the various terminologies in natural language processing. So guys, there's a lot to cover in today's session. Let's move ahead and take a look at our first topic. So why exactly are we using Python for artificial intelligence? Why aren't we using any other language, right? Now, there are a couple of reasons as to why Python is so popular when it comes to AI, machine learning, and deep learning. The first reason is less coding is required. Now, artificial intelligence has a lot of algorithms. If you have to implement AI in any code or in any problem, then there are going to be tons and tons of machine learning algorithms involved, deep learning algorithms involved, right? Now, testing all of these can become a very tiresome task. That's where Python usually comes in handy. Now, the language has something known as check as you code methodology, which eases the process of testing, right? You can check your program as you code it. Basically, as you're typing each sentence, your errors or your any sort of mistakes in your code will be given to you, right? So testing becomes much easier when it comes to Python. The next important reason why we're choosing Python is it has support for pre-built libraries, right? Python is very convenient for AI developers because all of the algorithms, machine learning algorithms and deep learning algorithms are already predefined in libraries, right? So you don't have to actually sit down and code each and every algorithm. That will take a lot of time, right? That's a very time consuming task. And thanks to Python, you don't have to do that because they have libraries and packages that have all the algorithms built in them, right? So if you want to run any algorithm, all you have to do is you have to call the function and load the library. That's all. It's as simple as that. Now, the next reason is ease of learning. So guys, Python is actually the most simplest programming language, right? If you ask me, I think it's the most easiest programming language. It's very similar to English language, right? If you read a couple of lines in Python, you'll understand what exactly the code is doing. It has a very simple syntax, and this simple syntax can be implemented to solve simple problems like addition of two strings, and it can also be used to solve complex problems like building machine learning models and deep learning models. So ease of learning is a major factor when it comes to why Python is chosen for artificial intelligence, right? Next, we have platform independent. So a good thing about Python is that you can get your project running on different operating systems, right? And what happens when you transfer your code from one operating system to another operating system is we find a lot of dependency issues. To solve that, Python has a couple of packages, such as there is a package known as PyInstaller. Right, this PyInstaller will take care of all the dependency issues when you're transferring your code from one platform to the other platform. So all of this support is provided by Python. The last reason is massive community support. This is a very important point because it is important that you have a large community that will help you out with any errors or with any sort of problems in your code, right? So Python has several communities and several forums and groups on Facebook. So if you have any doubts regarding any error, you can just post those errors in these groups and you'll have like a bunch of people helping you out, right? So guys, these are a couple of reasons as to why Python is chosen for artificial intelligence. It's actually considered the most popular and the most used language for data science, AI, machine learning, and deep learning. To prove that to you, here is a stat from Stack Overflow. Stack Overflow recently stated that Python is the fastest growing programming language. If you look at the graph, you can see that it has taken over JavaScript and Java and C hash, C++, and PHP, right? So Python is actually growing at an exponential rate, especially when it comes to data science and artificial intelligence. A lot of developers are very comfortable with the Python language because, it's a general purpose language, first of all. So most of the developers are already aware of Python. And then using the same language in order to solve complex problems like artificial intelligence, machine learning, and deep learning is something every developer wants, right? They want a simple language in order to code all the complex algorithms or the complex models, right? So that's why Python is the best choice for artificial intelligence. For those of you who are not aware of Python programming and don't know much about Python, I'm going to leave a couple of links in the description box, right? You can go through those links and study a little bit more about how Python works or how the coding part works, right? I'm going to be focusing mainly on artificial intelligence and I'll be showing you a lot of demos. So those of you who are not aware of Python, make sure you check the description box, right? Next, I'm going to discuss the different Python packages for artificial intelligence. Now, these are the packages that are specifically for machine learning, deep learning, natural language processing, and so on. So let's take a look at all these packages. So first, we have TensorFlow. If you are currently working on a machine learning project in Python, then you must have heard of this popular open source library known as TensorFlow. Right? This library was developed by Google in collaboration with Brain Team. TensorFlow is used in almost every Google application for machine learning. Now, let me just discuss a few features of TensorFlow. It has a responsive construct, meaning that with TensorFlow, we can easily visualize each and every part of the graph, which is not an option when you're using other packages such as NumPy or Scikit, right? Another feature is that it's very flexible. Now, one of the most important TensorFlow features is that it is flexible in operability, meaning that it has modularity and the parts of which you want to make standalone, it offers you that option, right? It's very flexible in that way. It'll give you exactly what you want. Now, a good feature about TensorFlow is that you can train it on both CPU and GPU, right? So for distributed computing, you can have both these options. Also, it supports parallel neural network training. So TensorFlow offers pipelining in the sense that you can train multiple neural networks and multiple GPUs, which makes the models very efficient on any large scale system, right? So parallel neural network training is supported by TensorFlow, right? This is one of the most important features of TensorFlow. Apart from this, it has a very large community. And needless to say, if it has been developed by Google, then there's already a large team of software engineers who work on stability improvements and all of that, right? The next library I'm going to talk about is scikit-learn. Now, scikit-learn is a Python library that is associated with NumPy and SciPy, right? That's why it has the name scikit-learn. Now, this is considered to be one of the best libraries for working with complex data. There are a lot of changes that are being made in this library, and one modification is the cross-validation feature, which provides the ability to use more than one metric, right? Cross-validation is one of the most important and one of the most easiest methods for checking the accuracy of a model, right? So cross-validation is being implemented in scikit-learn. And apart from that, again, there are a large spread of algorithms that you can implement by using scikit-learn, right? These include unsupervised learning algorithms, starting from clustering, factor analysis, principal component analysis, to all the unsupervised neural networks. Scikit-learn is also very essential for feature extracting in images and text. So mainly scikit-learn is used for implementing all the standard machine learning and data mining tasks like reducing dimensionality, classification, regression, clustering, and model selection. Next up, we have NumPy. Now, NumPy is considered as one of the most popular machine learning libraries in Python. Now, let me tell you that TensorFlow and other libraries, they make use of NumPy internally for performing multiple operations on tensors. The most important feature of NumPy is the array interface. It supports multi-dimensional arrays, right? That's one of the most important features of NumPy. Another feature is it makes complex mathematical implementations very simple, right? It's mainly known for computing mathematical data. So NumPy is a package that you should be using for any sort of statistical analysis or data analysis that involves a lot of math. Apart from that, it makes coding very easy, and grasping the concept is extremely easy with NumPy. Now, NumPy is mainly used for expressing images, sound waves, and other mathematical computations. All right. Moving on to our next library, we have Theano. Theano is a computational framework which is used for computing multi-dimensional arrays. Right? Theano actually works very similar to TensorFlow, but the only drawback is that you can't fit Theano into production environments. But apart from that, Theano allows you to define, optimize, and evaluate mathematical expressions that involve multi-dimensional arrays. Right? This is another library that lets you implement multi-dimensional arrays. Features of Theano include tight integration with NumPy. An advantage of Theano is that you can easily implement NumPy arrays in Theano, right? That's why there's a connection between Theano and NumPy, because both of them effectively use multi-dimensional arrays. Transparent use of GPU. Now, performing data-intensive computations are much faster when it comes to Theano because of its use of GPU, right? Theano also lets you detect and diagnose multiple types of errors and any sort of ambiguity in the model. So guys, Theano was actually designed to handle the types of computations required for large neural network algorithms, right? It was mainly built for deep learning and neural networks. It was one of the first libraries of its kind, and it is considered as an industry standard for deep learning research and development. Theano is being used in multiple neural networks projects, and the popularity of Theano is only going to grow with time, right? A lot of people actually haven't heard of Theano, but let me tell you that this is one of the best ways to implement deep learning and neural network models. Moving on, we have Keras. Now, Keras is considered to be the most popular Python package. It provides some of the best functionalities for compiling models, processing your data sets, and visualizing graphs. It is also popular in the implementation of neural networks, right? It is considered to be the simplest package with which you can implement neural networks. In fact, in our today's demo for deep learning, we'll be implementing Keras in order to understand how neural networks work. Few of the features of Keras include that it runs very smoothly on both CPU and GPU. It supports almost all the models of a neural network, right? From fully connected, convolutional, pooling, recurrent, embedding, all of these models are supported by Keras. And not only that, you can combine these models to build more complex models. Keras is completely Python based, which makes it very easy to debug and explore, right? Since Python has a huge community of followers, it's very simple in order to debug any sort of error that you find while implementing Keras. So the libraries that I discussed so far were dedicated to machine learning and deep learning. For natural language processing, we have the most famous library known as the Natural Language Toolkit, which is an open source Python library mainly used for natural language processing, text analysis, and text mining. The main features include that it studies and analyzes natural language text in order to draw useful information from all this natural language text. It performs text analysis and sentimental analysis by performing tasks such as stemming, lemmatization, tokenization, and so on. Now, don't worry if you don't know what any of those terms mean. I'll be discussing all of those terms with you by the end of today's session. So guys, these were a couple of Python-based libraries which are very essential for implementing machine learning and deep learning and artificial intelligence when you're using Python, right? These libraries are perfect for implementing AI. So guys, if any of you have any doubts regarding the libraries, or if you want to learn more about the libraries, I will leave a couple of links in the description box. You can go through those videos as well. So now let's move on to the main topic of discussion, which is artificial intelligence. Now, before we get started with the demand of artificial intelligence, let me tell you that AI was invented long ago. AI goes back to the 19th century. It was not something that was recently invented, even though AI has recently gained a lot of popularity. we can say that in the past decade, AI has gained the maximum popularity. But it was actually invented in the 19th century. Now, especially in the year 1950, there was somebody known as Alan Turing. I'm sure a lot of you have heard about the Turing test. The Turing test is basically used to determine whether or not a machine is artificially intelligent, meaning that whether a machine can think intelligently like a human being, right? This was the first proposition, and this was one of the most important breakthroughs in artificial intelligence, right? Somebody known as Alan Turing, he published a landmark paper in which he speculated about the possibility of creating machines that think, right? So the Turing test was the first serious proposal in the philosophy of artificial intelligence. This was done in 1950. Right after this, we had eras of AI. We had the game AI, which was in 1951. Now, since the emergence of AI in 1950s, we have seen an exponential growth in its potential. Right? AI covers domains like machine learning, deep learning, neural networks, natural language processing, knowledge base, and so on. It's also made its way into computer vision and image processing. But the question is, if AI has been here for over half a century, why has it suddenly gained so much importance? Right? Why are we talking about artificial intelligence now? The main reasons for the vast popularity of AI are the following. Right? The first reason is more computational power. Now, AI requires a lot of computing power. Recently, many advances have been made and complex deep learning models can be deployed. And one of the greatest technology that made this possible are GPUs. Since the invention of GPUs, we can compute much more with our computers. Initially, we could barely process 1 GB of data, right? We only had hard disks to store additional memory and all of that. Now our computers can process tons and tons of data. So now we have more computational power, which is one of the main reasons behind why AI became so popular. So by having more computational power, it becomes much easier to implement artificial intelligence. Next reason is more data. Now, big data is one of the most important reasons behind the development of artificial intelligence. Now, AI and data science and machine learning, deep learning, all of these processes are here only because we have a lot of data at present. Now, the main idea behind all these technologies is to draw useful insights from data. Now, since we start generating a lot of data, we need to find a method that can process this much data and draw useful insights from data such that it benefits an organization or it grows a business. That's why artificial intelligence and machine learning comes into the picture, right? So more data led to the demand of artificial intelligence. Apart from this, we also have better algorithms now, right? We have state of the art algorithms. Most of them are based on the idea of neural networks, and these are constantly getting better. Neural networks are actually one of the most significant discoveries in artificial intelligence because with neural networks, you can take in thousand layers of input data, right? You can take in a lot of input data to perform computations. So through neural networks, we're actually able to solve a lot of problems, including healthcare problems, fraud detection problems, and so on. Another reason is broad investment. So, our universities and governments and startups and any tech giants like Google, Amazon, and Facebook, they are all investing heavily in artificial intelligence, which also led to the demand of AI. So, AI is rapidly growing both as a field of study and also as an economy, right? It's adding a lot to the economy. And I think this is the perfect time for you to get into the field of artificial intelligence because right now AI is in a really high demand. AI, machine learning, data science, all of this are of really high demand at present. Right, so this is the perfect time for you to get started with artificial intelligence. Now, let me tell you that the term artificial intelligence was first coined in the year 1956 by a scientist known as John McCarthy. Now, John McCarthy defined artificial intelligence as the science and engineering of making intelligent machines. Now, let me give you a descriptive definition of artificial intelligence. Artificial intelligence is the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. In a sense, artificial intelligence is a technique of getting machines to work and behave like humans. In the recent past, AI has actually been able to accomplish this by creating machines and robots that have been used in a wide range of fields, including healthcare, robotics, marketing, business analytics, and many more, right? So AI is actually a very vast field. It covers a lot of domains, including machine learning, natural language processing, knowledge base, deep learning, computer vision, and expert systems. So these are a few domains that AI covers. Now let's move on and discuss the different types of artificial intelligence. Now, guys, AI is structured along three evolutionary stages. You can say that AI is developed along three evolutionary stages. We have something known as artificial narrow intelligence, followed by artificial general intelligence, and finally, we have artificial super intelligence. Artificial narrow intelligence, which is also known as weak AI, it involves applying AI only to specific tasks. Many of the currently existing systems that claim to use artificial intelligence are actually operating as weak AI, which is focused on a narrowly defined specific problem. Now, take Alexa. Alexa is actually a good example of artificial narrow intelligence. It operates within a limited, predefined range of functions, right? There is no genuine intelligence or no self awareness, despite being a sophisticated example of weak AI. Google search engine, Sophia, and self driving cars, and even the famous AlphaGo fall under the weak AI category. Then we have something known as artificial general intelligence. This is also known as strong AI, and it involves machines that possess the ability to perform any intellectual task that a human being can. Now, guys, machines don't possess human like abilities. They have a very strong processing unit that can perform high level computations, but they're not yet capable of thinking and reasoning like a human. And there are also many who question whether it would be desirable. For example, Stephen Hawking warned that strong AI would take off on its own and redesign itself at an ever increasing rate. Humans who are limited by slow biological evolution couldn't compete and would be superseded. Right, so we have a lot of tech giants and a lot of geniuses who are actually worried if strong AI is ever implemented, it might take over the world. Right. So, guys, let me tell you that strong AI is something that has not been implemented yet. We are only at the first stage of artificial intelligence, which is artificial narrow intelligence, also known as weak AI. Right. We haven't yet reached strong AI or artificial super intelligence. So, artificial superintelligence is a term that refers to the time when the capabilities of a computer will surpass humans. Right? ASI is currently seen as a hypothetical situation as depicted in movies and science fiction books where machines have taken over the world. Right? So, artificial superintelligence is something that is very far off, but tech masterminds like Elon Musk believe that artificial superintelligence will take over the world by the year 2040. Right? There are a lot of people who are against the development of artificial general intelligence and artificial superintelligence. A lot of us believe that we should stick to weak AI and not move any further and risk the existence of human civilization. So, guys, let me know your thoughts about artificial intelligence in the comment section. I'd love to know what you guys think about AI and whether you all believe AI will take over the world or not. So now let's move on and talk about how artificial intelligence is different from machine learning and deep learning. A lot of people tend to assume that artificial intelligence, machine learning, and deep learning are the same because they have common applications, right? For example, Siri is an application of AI, machine learning, and deep learning. So, how are these technologies related, right? Or how are they different from each other? Now, artificial intelligence is the science of getting machines to mimic the behavior of human beings. Machine learning is the subset of artificial intelligence that focuses on getting machines to make decisions by feeding them data. Deep learning, on the other hand, is a subset of machine learning that uses the concept of neural networks to solve complex problems. So, to sum it up to you, artificial intelligence, machine learning, and deep learning are heavily interconnected fields. Right? Machine learning and deep learning aids artificial intelligence by providing a set of algorithms and neural networks to solve data driven problems. However, AI is not restricted to only machine learning and deep learning. Right? It covers a vast domain of fields which include natural language processing, object detection, computer vision, robotics, expert systems, and so on. Right? So AI is a very vast field. Guys, I hope I cleared the difference between AI, machine learning, and deep learning. Also, a lot of you might be confused about data science. Data science is now an umbrella term, right? Data science basically means to derive useful insights from data. So data science actually uses AI, machine learning, and deep learning, right? So it implements all of these three technologies in order to derive useful insights from data, right? Now let's move on to the most interesting topic in artificial intelligence, which is machine learning. Now, guys, the term machine learning was first coined by a scientist known as Arthur Samuel in the year 1959. Looking back, that year was probably the most significant in terms of technological advancements. In order to define machine learning, if you browse the internet for what is machine learning, you'll get at least 100 different definitions. In simple terms, machine learning is a subset of artificial intelligence which provides machines the ability to learn automatically and improve from experience without being explicitly programmed to do so. In a sense, it is the practice of getting machines to solve problems by gaining the ability to think. Now, the question here is, can a machine think or can a machine make decisions? Well, if you feed a machine a good amount of data, it will learn how to interpret, process, and analyze this data by using something known as machine learning algorithms. To give you a basic idea of how the machine learning process works, look at the figure on this slide. A machine learning process always begins by feeding the machine lots and lots of data. Now, by using this data, the machine is trained to detect any hidden insights and trends in the data. These insights are then used to build a machine learning model by using a machine learning algorithm in order to solve a problem. The basic aim of machine learning is to solve a problem or find a solution by using data. Now, moving ahead, I'll be discussing the machine learning process in depth, right? So don't worry if you haven't got the exact idea of what machine learning is. Now, the machine learning process involves building a predictive model that can be used to find a solution for a particular problem. A well defined machine learning process will have around 7 steps. It always begins with defining the objective, followed by data gathering or data collection. Then we have something known as preparing data, which is also called data pre-processing. Then we have data exploration or exploratory data analysis. This is followed by building a machine learning model. Then we have model evaluation and finally predictions. This is how the process of machine learning works. To understand the machine learning process, let's assume that you've been given a problem that needs to be solved by using machine learning. Let's say that the problem is to predict the occurrence of rain in your local area by using machine learning. Now, the first step is to define the objective of the problem. Right? At this step, we must understand what exactly needs to be predicted. In our case, the objective is to predict the possibility of rain by studying the weather conditions. So at this stage, it is essential to take mental notes on what kind of data can be used to solve this problem or the type of approach that you must follow to get to the solution. The questions you should be asking yourself is, what are we trying to predict? Right? Here we're trying to predict whether it'll rain or not. Right? You need to understand what are the target features. Target features are basically the variable that you need to predict. Here we need to predict a variable that will show us whether it's going to rain tomorrow or not. Then you must also understand what kind of data you will need to solve this problem. Apart from that, you need to know what kind of problem you're facing. Is it a binary classification problem or is it a clustering problem? Now, if you don't know what classification and clustering is, don't worry. I'll be talking about all of these things in the upcoming slides. So your first step is to define the objective of your problem. You need to understand what exactly needs to be done here, right? How can you solve this problem? Moving on, your next step is to gather the data that you need. At this stage, you must be asking questions such as, what kind of data is needed to solve this problem? Is the data available to me? And if it's not available, how can I get the data? Right? Once you know the type of data that is required, you must understand how you can derive this data. Data collection can be either done manually or it can be done by web scraping. But don't worry if you're a beginner and you're just looking to learn machine learning, you don't have to worry about getting the data. There are thousands of data resources on the web. You can just download the data set and you can get going. Coming back to the problem at hand, the data needed for weather forecasting includes measures such as humidity level, your temperature, the pressure, the locality, whether or not you live in a hill station, and so on. Such data must be collected and it has to be stored for analysis. This is where you collect all the data. Now, moving on to step number 3 is data preparation. The data that you collected is almost never in the right format. All right, even if you collect it from an internet resource, if you download it from some website, even then your data is not going to be clean, right? It's not going to be in the correct format. There's always going to be some sort of inconsistencies in your data. Inconsistencies include any missing values or any redundant variables, duplicate values. All of these are inconsistencies. Removing all of this is very essential because they might lead to any wrongful computation. Therefore, at this stage, you can scan the entire data set for any missing values and you have to fix them here itself. Now, actually, this is one of the most time consuming steps in a machine learning process. If you ask a data scientist which step he hates the most or which step is, the most time consuming, they're probably going to tell you data processing and data cleaning, right? It's one of the most tiresome tasks because you need to look at all the values that are there. You need to find any missing values, any data that is not relevant to you, right? All of this has to be removed such that you can analyze the data in a better way. Now, step number 4 is exploratory data analysis. So guys, this stage is all about getting deep into your data and finding all the hidden data mysteries. EDA or exploratory data analysis is like the brainstorming stage of machine learning. Data exploration involves understanding the patterns and the trends in your data. So at this stage, all the useful insights are drawn and any correlations between the variables are understood. For example, in the case of predicting rainfall, we know that there is a strong possibility of rain if the temperature has fallen low. Such correlations have to be understood and mapped at this stage. EDA is actually the most important step in a machine learning process because here is where you understand your data. You understand how your data is going to help you predict the outcome. Moving on to step number 5, we have building a machine learning model. So all the insights and all the patterns that you got from your data exploration stage, those insights are used to build the machine learning model. So this stage always begins by splitting the data set into two parts, that is training and testing data. Now remember that the training data will be used to build and analyze the model. The model is basically the machine learning algorithm that predicts the output by using the data that you feed to it. An example of machine learning algorithm is logistic regression and linear regression. All of these are machine learning algorithms. Now, don't worry about choosing the right algorithm, right? First, we'll focus on what the machine learning process is. But anyway, choosing the right algorithm will depend on several factors, right? It depends on the type of problem you're trying to solve, the data set, and the level of complexity of the problem. In the upcoming sections, we'll discuss all the different types of problems that can be solved by using machine learning. Moving on to step number 6, we have model evaluation and optimization. Now, after you build a model by using the training dataset, it is finally time to put the model to a test. The testing dataset is used to check the efficiency of the model and how accurately it can predict the outcome. Now, once the accuracy is calculated and any further improvements in the model, they have to be implemented at this stage. Methods like parameter tuning and cross-validation can be used to improve the performance of the model. Before I move any further, I don't know if all of you know what training and testing dataset means. In machine learning, the input data is always divided into two sets. We have something known as the training dataset and we have something known as the testing dataset. So in machine learning, you always split the data into two parts, right? This process is known as data splicing. Now, the training data set will be used to build the machine learning model, and the testing data set will be used to test the efficiency of the model that you built. This is what training and testing data set is. They're not any different data that you derive, they're the same as the input data set. The only thing is you are splitting the data set so that you can train the model on one data and test the model on another data. Now remember that the training data set is always larger in size when compared to the testing data set, because obviously you are training and building the model by using the training data set. The testing data set is just for evaluating the performance of your model. Now let's move on and understand step number 7, which is predictions. Now once the model is evaluated and you've improved the model, it is finally used to make predictions. The final output can be a categorical variable or it can be a continuous quantity, right? All of this depends on the type of problem you're trying to solve. Don't worry, I'll be discussing the type of problems that can be solved using machine learning in the upcoming slides. In our case, for predicting the occurrence of rainfall, the output will be a categorical variable. Categorical variable is anything that has some categorical value. For example, gender is a categorical variable. Gender has either male, female, or other. It has a defined set of values. That is a categorical variable. So guys, that was the entire machine learning process. Now, as we continue with this tutorial, in the upcoming sections, I will be running a demo in Python in which we will be performing weather forecasting. So make sure you remember all these steps that I spoke about because I'll be going through all these steps by using Python. We'll be coding all of this that we just spoke about. Now, the next topic we're going to discuss is the types of machine learning. A machine can learn to solve a problem by following any one of the three approaches. You can say that there are three ways in which a machine learns. The three ways are supervised learning, unsupervised learning, and reinforcement learning. These are the three methods in which you can train a machine to learn. So first, let's discuss supervised learning. So what is supervised learning? Supervised learning is a technique in which we teach or train the machine by using data which is labeled. To understand this better, let's consider an analogy. As kids, we all needed guidance to solve math problems. At least I had a really tough time solving math problems. Yeah, so our teachers always helped us understand what addition is and how it is done. Similarly, you can think of supervised learning as a type of machine learning that involves a guide. The label dataset is a teacher that will train the machine to understand the patterns in the data. The label dataset is nothing but the training dataset. So to better understand this, consider the figure. Right here, we are feeding the machine images of Tom and Jerry, and the goal is for the machine to identify and classify the images into two separate groups. Basically, one group will contain Tom images and the other group will contain images of Jerry. Now pay attention to the training dataset. The training dataset that is fed to a model is labeled, as in we're telling the machine, listen, this is how Tom looks and this is how Jerry looks. We're basically labeling each data point that we're feeding to the machine, right? If the image is of Tom's, we've labeled it as Tom, and if the image is a Jerry image, then we're going to label it as Jerry. By doing this, you're training the machine by using labeled data. So to sum it up, in supervised learning, there is a well-defined training phase done with the help of labeled data. Right? The rest of the process is the same. After you feed the machine labeled data, you're going to perform data cleaning, then exploratory data analysis, followed by building the machine learning model and then model evaluation, and finally your predictions. Also, one more point to remember is that the output that you're going to get in a supervised learning algorithm is a labeled output. This Jerry will be labeled as Jerry and this Tom will be labeled as Tom. Basically, you'll get a labeled output. Now let's understand what is unsupervised learning. Unsupervised learning involves training by using unlabeled data and allowing the model to act on that information without any guidance. So think of unsupervised learning as a smart kid that learns without any guidance. In this type of machine learning, the model is not fed with any labeled data. As in, the model has no clue that this image is Tom and this image is Jerry. It figures out patterns and the differences between Tom and Jerry on its own by taking in tons of data. For example, it identifies prominent features of Tom such as pointy ears, bigger in size and so on to understand that this image is of type 1. Similarly, it finds such features in Jerry and knows that this is another type of image, maybe type 2. Right? Therefore, it classifies the images into two different clusters without knowing who is Tom and who is Jerry. Now, the main idea behind unsupervised learning is to understand the patterns in your data set and form clusters based on feature similarity. Basically, it'll feature similar images or similar data points into one cluster, and it'll form another cluster which is totally different from the first cluster. So look at the output over here. The unlabeled output is basically clusters or groups of two different data. Next, we have something known as reinforcement learning. Now, reinforcement learning is comparatively different, right? It's pretty different from supervised and unsupervised. It is basically a part of machine learning where you put an agent in an environment, and this agent learns to behave in the environment by performing certain actions and observing the rewards which it gets from these actions. To understand reinforcement learning, imagine that you were dropped off at an isolated island. What would you do? Initially, we'd all panic, right? But as time passes by, you will learn how to live on the island. You will explore the environment. You will understand the climate conditions. You'll understand the type of food that grows there. You'll know what is dangerous to you and what is not. You'll understand which food is good for you and which is not. This is exactly how reinforcement learning works. It involves an agent, which is basically you stuck on the island, that is put in an unknown environment, which is the island, where the agent must learn by observing and performing actions that result in rewards. Reinforcement learning is mainly used in advanced machine learning areas such as self-driving cars, AlphaGo, and so on. So guys, that sums up the types of machine learning. Before we go any further, I'd like to discuss the difference between supervised, unsupervised, and reinforcement learning. Now, first of all, we have the definition. Supervised learning is all about teaching a machine by using labeled data. Unsupervised learning, like the name suggests, there is no supervision over here. The machine is trained on unlabeled data without any guidance. Reinforcement learning is totally different. Here you have an agent who interacts with the environment by producing actions and discovers some errors and rewards. Now, the type of problem that is solved using supervised learning is regression and classification problems. We'll discuss what regression, classification, and clustering is in the upcoming slide, right? So don't worry if you don't know what it is. Unsupervised learning is mainly to solve association and clustering problems. Reinforcement learning is for reward-based problems. Now, what is the type of data in supervised learning? It is labeled data. That is the main difference between supervised and any other type of machine learning. In supervised, you have labeled data. In unsupervised, we have unlabeled data. Whereas in reinforcement learning, we have no predefined data at all. The machine has to perform everything from scratch. It has to collect data, analyze, do everything on its own. Now, the training in supervised learning is external supervision, meaning that we have external supervision in the form of the labeled training dataset. In unsupervised, there is obviously no supervision. There is an unlabeled data set, therefore there's no supervision. In reinforcement learning, there is no supervision at all. Now, the approach to solving supervised learning problem is basically you're going to map your labeled input to your known output. In unsupervised learning, the machine is going to understand the patterns and discover the output on its own. Reinforcement learning, here the agent will follow something known as a trial and error method, right? It's totally based on the concept of trial and error. Popular algorithms under supervised learning are linear regression, logistic regression, support vector machines, and so on. Under unsupervised learning, we have the famous k-means clustering algorithm. Under reinforcement learning, we have the Q-learning algorithm, which is one of the most important algorithms. It is basically the logic behind the famous AlphaGo game. I'm sure all of you have heard of that. So guys, these were the differences between supervised, unsupervised, and reinforcement learning. Now let's move on and discuss the type of problems that you can solve by using machine learning. Now there are three types of problems in machine learning. Now any problem that needs to be solved in machine learning can fall into one of these three categories. Now what is regression? In this type of problem, the output is a continuous quantity. For example, if you want to predict the speed of a car given the distance, that means it is a regression problem. First of all, what is a continuous quantity? A continuous quantity is any variable that can hold a continuous value. A continuous variable is any variable that can have infinite number of values. For example, the height of a person or the weight of a person is a continuous quantity, right? I can have a weight of 50.1 kgs or 50.12 or 50.112 kgs. This is a continuous quantity. Regression problems can be solved by using supervised learning algorithms. Another type of problem is the classification problem. Here the output is always a categorical value. Classifying emails into two classes, for example, classifying your email as spam and non-spam, is a classification problem. Here again, you'll be using supervised learning classification algorithms such as support vector machines, naive Bayes, logistic regression, and so on. Then we have clustering problem. Right? This type of problem involves assigning the input into two or more clusters based on feature similarity. For example, clustering the viewers into similar groups based on their interest or based on their age or geography can be done by using unsupervised learning algorithms like k-means clustering. One thing you need to understand is under supervised learning, you can solve regression and classification problems. Under unsupervised learning, you can solve clustering problems. Reinforcement learning is something else altogether, right? You can solve reward-based problems and more complex and deep problems. So now let's move on and understand the different machine learning algorithms. Now, I will not be going into depth for machine learning algorithms because there are a lot of algorithms to cover, but we have content around almost every machine learning algorithm out there. So I'll be leaving a couple of links in the description box, right? You can check out all these links and understand how each of these machine learning algorithms work in depth. So I'm just going to show you a hierarchical diagram of how the algorithms are structured. So under machine learning, we have three types of learning. We have supervised, unsupervised, and reinforcement. Under supervised learning, we have regression and classification problems. And under unsupervised learning, we have clustering problems. Reinforcement learning is completely different. I'll be leaving a link in the description specifically for reinforcement learning. You can check out the entire content of reinforcement learning there. Now, regression problems can be solved by using linear regression. Algorithms such as linear regression, decision trees, and random forests can also be used in regression problems. But usually, decision trees and random forests, all of these are used to solve classification problems. Famous classification algorithms include k-nearest neighbor, which is basically KNN, decision trees and random forest, logistic regression, naive Bayes, support vector machines. All of these are classification algorithms. Coming to unsupervised learning, we have clustering and association analysis. Right? Clustering problems can be solved by using k-means, and association analysis can be solved by using a priori algorithm. A priori algorithm is mainly used in market basket analysis. Right? For this algorithm as well, I'll be leaving a link in the description. We've performed a very excellent demo wherein we've showed how market basket analysis can be done by using a priori algorithm. Markov model is also explained in one of the videos. I'll be leaving that link in the description box. Now, to sum up machine learning to you, I'll be running a small demonstration in Python. Right? Like I promised earlier, I will be using Python to understand the whole machine learning process. All right, so let's get started with that demo. So guys, for those of you who don't know Python, I will leave a couple of links in the description box so that you understand Python. But apart from that, Python is pretty understandable. If you just look at the code, you'll know what exactly I'm talking about. Right? So don't worry. And also I'll be explaining everything in the code. So I'm using PyCharm in order to run the demo. Right? So guys, like I said, if you don't know Python, I'll leave a couple of links in the description box. You can go through those videos as well. The main aim of our demo is to build a machine learning model that will predict whether or not it will rain tomorrow by studying the past dataset. Now, this dataset contains around 145,000 observations on the daily weather conditions as observed in Australia. Right? The data set has around 24 features, and we will be using 23 features out of that to predict the target variable, which is rain tomorrow. So this data set I collected from Kaggle. Right? For those of you who don't know, Kaggle is an online platform where you can find hundreds of data sets, and there are a lot of competitions held by machine learning engineers and all of that. It's an interesting website. Now, the problem statement itself is to build a machine learning model that will predict whether or not it will rain tomorrow. This is clearly a classification problem. The machine learning model has to classify the output into two classes, that is either yes or no. Yes will stand for it will rain tomorrow, and no will basically denote that it will not rain tomorrow. Right? This is a classification problem. So I hope the objective is clear. Right, so we'll begin the demonstration by importing the required libraries. So first of all, for mathematical computations, we'll be importing the NumPy library. We'll also be importing the pandas library for data processing. Next, we will load the CSV file. Basically, my data is stored in a CSV format in this file. Weather.os.csv is my data set. So basically, I've saved this file in this path. Right, so that's what I'm doing here. I'm loading my data set. and I'm storing it in a variable known as df. Next, what we'll do is we'll see the size of our data frame. Let's print the size of the data frame. We'll also display the first 5 observations in our data frame. So let's look at the output. Basically around 145,000 observations and 24 features. Now 24 features are basically the variables that are there in my data set. For example, date is a variable, location is a variable, minimum temperature, till rain tomorrow, all of these are variables. So I have around 24 features in my data set, right? Now the variable that I have to predict is rain tomorrow. Okay. If the value of rain tomorrow is no, it denotes that it will not rain tomorrow. But if the value is yes, then it will denote that it will rain tomorrow. So rain tomorrow is basically my target variable, right? I'll be finding out whether it's going to rain tomorrow or not. So this is my target variable, also known as your output variable. My input variables will be the other 23 variables: date, location, minimum temperature, rain today, risk. All of this will be my input variables. Now these variables are also known as predictor variables. Basically, they're used to predict your outcome. So these are also known as predictor variables. Now the next step is checking for null values. This is basically data pre-processing. Let me just comment it for you. This is data preparation or data. Right, so this stage is data pre-processing. Right here we start checking for any null values or any missing values. That's exactly what I'm doing over here. I am checking for any missing or null values in my data set. If you notice the output, it shows that the first 4 columns have more than 40% null values, right? So it's always best for us to remove features or such variables because they will not help us in our prediction. Now, during data pre-processing, it is always necessary to remove the variables that are not significant. Unnecessary data will just increase our computations. That's why it's always best if we remove the unwanted or unnecessary variables. Now, apart from removing these 4 variables, we'll also remove the location variable and we will remove the date variable, right? I'll come to this variable in a minute. We'll also be removing location and date variable because both of these variables are not needed in order to predict whether it'll rain tomorrow, right? We do not need to know the location and the date. Now, we'll also be removing this risk variable. Risk variable basically tells us the amount of rain that might occur the next day. Right now, this is a very informative variable and it might actually leak some information to our model. By using this variable, we'll easily be able to predict and there's no point of doing that. This variable will give us too much information. Right? So that's why we're going to remove this variable as well. It'll leak a lot of information. So after that, if you print the shape of your data frame, we have only 17 variables and so many observations. Now after this, we'll just look at any null values and we'll remove them. This drop.any function will just remove all the null values, right? Then if you print the shape of your data frame, we'll have around 112,000 rows with 17 variables. This is the shape of the data set after removing all the null values and all the redundant or unnecessary variables. Now it's time to remove the outliers in the data. So after you remove any null values, we should also check our data set for any outliers. An outlier is a data point that is very different from your other observations. Outliers usually occur because of miscalculations while collecting the data. These are some sort of errors in your data set. So in this whole code snippet, we're just getting rid of outliers. This is the output that we get, all our outliers. Next, what we'll be doing is we will be assigning zeros and ones in the place of yes and no. The only thing is we're going to change the categorical variables from yes and no to 0 and 1. Right? That's exactly what we're doing over here. Now, if there are any unique values such as any character values which are not supposed to be there, we'll be changing them into integer values. That's all we're doing over here. After this, we'll be normalizing our data set. This is a very important step because in order to avoid any biasness in your output, you have to normalize your input variables. Right? To do this, we can make use of the min-max scalar function, which Python provides in a package known as sklearn. You can use that package in order to normalize your data set. So after normalizing our data set, this is what our data set looks like. This is before normalization. You can see that these are in 2 digits, whereas these values are in single digits, right? This causes a lot of biasness. But once we normalize the values, we know that all of the values are in a similar range. We have everything in decimals, right? So normalization is something that has to be performed, because if you have a data set like this, your output is not going to be correct. And that's why we perform normalization. So now that we are done with pre-processing, what we're going to do is it's time for exploratory data analysis. Let me just comment it for you. This is exploratory data analysis. So basically here what we're going to do is we're going to analyze and identify the significant variables that will help us predict the outcome. To do this, we'll be using the select k-best function, which is present in the sklearn library. There's a predefined function in Python called select k-best, which will basically select the most significant predictor variables in our data set. When we run that line of code, we get these three variables to be the most significant variables in our data set. Right? The main aim of this demo is to make you understand how machine learning works. That's why to simplify the computation, we'll assign only one of these significant variables as the input. Instead of taking all three variables as input, we'll select one variable and we'll take that as the input, and the output is the rain tomorrow variable. So basically, we are creating a data frame of all the significant variables. Basically, we're choosing this variable in order to predict our outcome. Obviously, our outcome is rain tomorrow variable. So our input is humidity level and our output is to detect whether it'll rain tomorrow. The next step is data modeling. All of you are aware of what data modeling is. To solve this, we'll be using classification algorithms over here. We'll use logistic regression. We will use random forest classifier, which is another machine learning algorithm. We'll also use the decision tree classifier and support vector machine. Right? We'll be using all of these algorithms in order to predict the outcome. We'll also check which algorithm gives us the best accuracy. So guys, we're just using multiple algorithms or multiple classification algorithms on the same data set. We're not doing anything very complex over here. So we start by importing all the necessary libraries for the logistic regression algorithm. We're also going to import time because we'll be calculating the accuracy and the time taken by the algorithm to get the output. So the first step is data splicing. I've already mentioned data splicing is splitting your data set into your testing data set and into your training data set. That's exactly what we're doing over here. So 25% of your data is assigned for the testing data and the remaining 75% is your training data. Here you're creating the instance of the logistic regression algorithm. This is an instance that you created. Then you'll fit the model by using your training data set. So basically, to build your machine learning algorithm, you'll be fitting your training data set. So xtrain and ytrain variables have your training data set. After that, you will be evaluating the model by using your testing data set. Then you'll calculate the accuracy score, right? I'll also be printing the accuracy using logistic regression and the time taken using logistic regression. Let's look at the accuracy. Don't worry about these warnings, they are not important. So accuracy using logistic regression is around 0.83%, which is 83% accuracy, approximately 84%. And this is the time taken. So the accuracy is actually pretty good, right? 84% is a good number. Then we have random forest classifier. Here again, we'll import the libraries that are needed to run random forest classifier. Then we're again calculating the accuracy and the time taken by the classifier. Data splicing, like I mentioned, splitting the data into testing and training data set. Then you're just building the model by using the training data set. After that, you'll evaluate the model by using the testing data set and you'll finally calculate the accuracy. The accuracy using random forest is again approximately 84%, which is a really good number. Then we have decision tree classifier. Here again, we'll be importing the libraries needed for this classifier. We'll be calculating the accuracy and the time taken by this classifier. Data splicing, followed by building the model by using the training data set, evaluating the model by using the testing data set, and finally calculating the accuracy and printing the accuracy. So let's see the accuracy using decision tree classifier. Again, we have an accuracy of around 83 to 84%. This is a pretty good number. And last, we're going to do this by using another classification algorithm known as support vector machine. Here again, we are importing the needed libraries. Then we're calculating the accuracy and the time, performing data splicing. Then we're building the model by using the training data set, testing the model using the testing data set, and finally printing the accuracy. So guys, all the classification models gave us an accuracy score of approximately 84% to 83%. So this is exactly how a machine learning process works, right? You begin by importing all your data, then you perform data pre-processing or data cleaning. After that, you perform exploratory data analysis, where you understand the important patterns or the important variables in your data set. After that, you build a model, then you will evaluate the model by using the testing data set, and finally calculate the accuracy. I showed you all the steps in the machine learning process by using a practical demonstration in Python. So guys, give yourself a pat on the back because we just understood the whole machine learning process with a small implementation in Python. Now let's move on to our next topic, which is limitations of machine learning. Before we understand what deep learning is, it's important to know the limitations of machine learning and why these limitations gave rise to the concept of deep learning. One major problem in machine learning is machine learning algorithms and models are not capable of handling high dimensional data. Right? We can take in data with 20 to 30 feature variables, but when it comes to data sets which have thousands of variables, machine learning does not work. Machine learning is not capable enough to process that much data. So high dimensional data cannot be analyzed, processed, and modeled by using machine learning. Another limitation is that it cannot be used in image recognition and object detection because these applications require the implementation of high dimensional data. Another major challenge in machine learning is to tell the machine what are the important features it should look for in order to precisely predict the outcome. So basically, you're selecting the important features for the machine learning model and you're telling them, like, these are the important features, and this is what you should use in order to build the model. This process is known as feature extraction. Now, in machine learning, this is a manual process. You're going to manually input as a programmer. You're going to tell that these are the important predictor variables. But what happens when your data set has hundreds of variables? How are you going to sit and choose every variable and perform analysis on each variable to understand which is a really significant variable? That's going to become a very tedious task, right? It's not possible for you to manually sit down with 100 variables, check the correlation with each variable, and understand which variable is significant in predicting the output. So performing feature extraction manually is very tedious, and that is one of the major limitations of machine learning. Now, deep learning comes to the rescue to all of these problems. So let's understand what deep learning is and why we have deep learning in the first place. So deep learning is actually one of the only methods by which we can overcome the challenge of feature extraction. This is because deep learning models are capable of learning to focus on the right features by themselves, requiring minimal human intervention, meaning that feature extraction will be performed by the deep learning model itself. You don't have to manually tell that this feature is important, that feature is important, choose this feature for predicting the output. All of this is not needed in deep learning. The model itself will learn which features are most significant in predicting the output. Also, deep learning is mainly used to deal with high dimensional data, right? It is based on the concept of neural networks and is often used in object detection and image processing. This is exactly why we need deep learning. It solves the problem of processing high dimensional data and manual feature extraction. Now, how exactly does deep learning work? Now, deep learning mimics the basic component of the human brain called the brain cell. The brain cell is also known as a neuron. So, inspired from a neuron, an artificial neuron was developed. Deep learning is based on the functionality of a biological neuron. So, let's understand how we mimic this functionality in an artificial neuron. Now, guys, an artificial neuron is also known as a perceptron. Let's understand what this biological neuron does and how deep learning is based on this concept. In a biological neuron, you can see these dendrites, right? In this image, you see something known as dendrites. These dendrites are used to receive any input. These inputs are summed in the cell body, and through the axon, it is passed on to the next neuron. So similar to the biological neuron, a perceptron or an artificial neuron receives multiple inputs applies various transformations and functions, and provides an output. Right? So that's how artificial neural networks, or that's how deep learning works. Now, guys, the human brain consists of multiple connected neurons called a neural network. Similarly, by combining multiple perceptrons, we've developed what is known as deep neural networks. The main idea behind deep learning is neural networks, and that's what we're going to learn about. So now let's understand what exactly deep learning is. Deep learning is a collection of statistical machine learning techniques used to learn feature hierarchies based on the concept of artificial neural networks. So the main idea behind deep learning is to use the concept of neural networks. A deep neural network will have three layers. Okay, there's something known as the input layer, followed by the hidden layers, and then we have the output layer. The input layer is basically the first layer, and it receives all the inputs. So all the inputs are fed into this input layer. The last layer is obviously the output layer. This layer will provide your desired output. Now, all the layers between the input and your output layer are known as the hidden layers. Now, the number of hidden layers in a deep learning network will depend on the type of problem you're trying to solve and the data that you have. We'll get into depth of what exactly a hidden layer does, but for now, this is how a neural network is structured in deep learning. So guys, deep learning is used in highly computational use cases such as face verification, self-driving cars, and so on. Right, so let's understand the importance of deep learning by looking at a real-world use case. So I'm sure all of you have heard of the company PayPal. Now, PayPal makes use of deep learning to identify any possible fraudulent activities. So the company makes use of deep learning for fraud detection. Now, PayPal recently processed over $235 billion in payments from 4 billion transactions by its more than 170 million customers. So basically, it processed this much data by using deep learning. PayPal uses machine learning and deep learning algorithms to mine data from the customer's purchasing history, in addition to reviewing patterns of any sort of fraud stored in the database, and it will do this to predict whether a particular transaction is fraudulent or not. Now, the company has been relying on deep learning and machine learning technology for around 10 years. Initially, the fraud monitoring team used simple linear models, right? They use machine learning. But over the years, the company switched to more advanced machine learning technology called deep learning. This shows how deep learning is used in more advanced and more complicated use cases. The fraud risk manager and the data scientist at PayPal, he quoted that what we enjoy from more modern, advanced machine learning is its ability to consume a lot more data, handle layers and layers of abstraction, and be able to see things that a simpler technology would not be able to see, even human beings might not be able to see. This is exactly what he quoted. He said that a simple linear model is capable of consuming around 20 variables. But with deep learning technology, you can run thousands of data points. He also quoted that there is a magnitude of difference. You will be able to analyze a lot more information and identify patterns that are a lot more sophisticated. So by implementing deep learning technology, PayPal can finally analyze millions of transactions to identify any fraudulent activity. This is how PayPal makes use of deep learning. Not only PayPal, we also have Facebook, right? Facebook makes use of deep learning technology for face verification. You've all seen the tagging feature at Facebook, where we tag our friends in photos. All of that is based on deep learning and machine learning. So guys, that was a real world use case to make you understand how important deep learning is. Now let's move on and look at what exactly a perceptron is, right? We'll be going in depth about deep learning. A perceptron is basically a single layer neural network that is used to classify linear data. It is the most basic component of a neural network. Now, a perceptron has four important components. It has something known as inputs, weights and bias, summation functions, activation, and transformation functions. These are four important parts of a perceptron. Now, before I discuss this diagram with you, let me tell you the basic logic behind a perceptron. There is something known as inputs, right? The input x, here you can see x1, x2 till xn. So let me explain the structure of a perceptron. What you're going to do is you're going to input variables into the perceptron, right? This x1, x2 till xn basically stands for input. W1, W2 till Wn stands for the weight assigned to each of these inputs, right? There is a specific weight that will be randomly initialized in the beginning for each of your input. Next, you have something known as the summation element. Here, what you do is you multiply the respective input with the respective weight and you add all these products, right? That is basically your summation function. After this is what is your transfer function, also known as activation function, right? The activation function will basically map your input to your desired output. So your input will go through these processes. It will go through summation and activation function in order to get to the output. So guys, remember that the neural networks work the same way as the perceptron. So if you want to understand how deep neural networks work, you need to understand what a perceptron does. A deep neural network is nothing but multiple perceptrons. So let me tell you how the entire thing works once again. So basically all your inputs are multiplied with their respective weights. Now you add all the multiplied values and you call them as a weighted sum. You use the summation function to add all of this. After that, you apply the weighted sum to the correct activation function or the transfer function. Activation function is very similar to a function in our brain. The neurons become active in our brain after a certain potential is reached. That threshold is known as the activation potential. So mathematically, there are a few functions which represent the activation function. Basically, the signum, the sigmoid, the tanh, all of these are activation functions. You can think of activation function as a function that maps the input to the respective output. Then I spoke about something known as weights and biases. All right, now you must be wondering, why do we have to assign weights to each of our input? Weights basically show the strength of a particular input or how important a particular input is for predicting the output. In simple words, the weightage denotes the importance of an input. Bias is basically a value which allows you to shift the activation function curve in order to get a precise output, right? So that's exactly what weights are. I hope all of you are clear with inputs, weights, summation, and activation function. Also, one important thing I forgot to mention in a perceptron is a single layer perceptron will have no hidden layers, right? There'll only be an input layer, an output layer, and a couple of transformation functions in between. That's all will be there in a perceptron. Now, a perceptron, like I mentioned, is used to solve only linear problems. If you look at this data distribution, how do you think we can solve this? This data is not linearly separable. So you cannot use a single layer perceptron to separate this data. Right? That's why we need something known as a multi-layer perceptron with back propagation. I'll be explaining this in the next slide. So complex problems that involve a lot of parameters and high dimensional data can be solved by using multiple layer perceptron. Now a multi-layer perceptron is the same as a single layer perceptron. The only difference is that a multi-layer perceptron will have hidden layers. So the number of hidden layers in a model depends upon various factors. I told you it depends on the complexity of the problem you're trying to solve. It depends on the number of inputs in your data and so on. So it works in the same way. All your inputs are multiplied with your weights and then you do the summation and then there is a transformation function or a activation function. While designing a neural network, in the beginning itself I told you we initialize weights with some random values. We do not have some specific value for each weightage. Initially, we've selected random values. It is always important that whatever weight values we have selected will be correct. Now, whatever weight values we've assigned to each input, it denotes the importance of that input variable. So we need to assign the weights in such a way, or we need to update the weights in such a way that it denotes the significance of that particular input. So initially we are selecting some random value for weight. And let's say that we use this weight value to get our output. Now what happens is the output is actually way different or it is not precise when compared to our actual output. Basically the error value is very huge. So how will you reduce the error? The main thing in a neural network is the weightage that you give to an input variable. right? Depending on the weightage that you give to an input variable, you're telling the neural network how important that variable is. Now, what if you randomly give some weightage and your output is wrong? The first thing that comes into your mind is that you need to change the weight, because the weight signifies the importance of a variable. So basically what we need to do is we need to somehow explain to the model to change the weight in such a way that the error becomes minimum. Let's put it in another way. So basically we need to train our model. One way to train our model is called as backpropagation. So in backpropagation, what happens is once you've initialized a weight to each of the input, you calculate the output, right? You get an output, and let's say you have a very high error value in that output. What you'll do is you'll backpropagate, as in you'll go back to the weight and you'll keep updating the weight in such a way that your error becomes minimum. This is exactly what backpropagation is. You'll be going back to the first layer, you'll be updating each of the weights in such a way that your output is more precise. So guys, basically the weight and the error in a neural network is highly related. By updating the weight in a particular way, your error will decrease. So you need to figure out how you need to update the weight. Do you have to increase the weight or decrease the weight? Once you figure out whether you have to increase or decrease the weight, you have to just follow that direction in such a way that your error is minimized. That's exactly what backpropagation is. So the final output of backpropagation is you're going to select the weight that minimizes the error function. And then you're going to use that weight to solve the whole problem. Right? This is what backpropagation is about. Now, in order to make you understand deep neural networks, let's look at a practical implementation. So again, guys, I'll be using Python to run the demo. If you don't have a good idea about Python, check the description. I'll leave a couple of links about Python programming. Now, in this demo, I'll be walking you through one of the most important applications of deep learning. I will demonstrate how you can construct a high-performance model to detect credit card fraud. Right? We'll be using deep learning models to do this. Now, before that, let me just tell you something about our data set. Right? The data set contains transactions made by credit cards in the year September 2013 by European cardholders. This data set presents transactions that occurred in 2 days, where we have 492 frauds out of 285,000 transactions, approximately 285,000 transactions. Out of these transactions, 492 were frauds, and the data set is quite unbalanced, right? The positive class accounts for 0.172%. So the positive class, basically the fraudulent class. So again, we're going to start by importing the required packages. We're going to import keras, matplotlib library, seaborn library, and sklearn for pre-processing. Right? Again, min-max scaler, which is for normalization. We're going to import our data set and store it in this variable. Right? This is the path to my data set. My data set is in the CSV format, or also known as comma separated version. Now we're going to print out the first 5 rows of our data set. Right? Let's take a look at the output. So here is the time of the transaction, V1, V2, V3, etc. These are all the features of our data set. I'm not going to go into depth of what these features stand for, because this demo is all about understanding deep learning. Now these V1, V2, V3, these are all predictor variables which will help us predict our class. So guys, don't worry about what these features are. These features are just information and details about your transaction, such as the amount you spend or the time of transaction and so on. So here we have the amount variable, which denotes the amount spent. After that, we have the class variable. Now this class variable is your output variable or your target variable. So your class is basically your output variable. Value 0 denotes that there has been no fraudulent activity. But if you get a class of 1, it means that this transaction is a fraudulent transaction. For example, this transaction is not fraudulent. That's why we have a value of 0 over here. All right, so this is our data set. Next, what we're doing is we're counting the number of samples for each class, right? We have class 0 and class 1, where in class 0 denotes the normal transaction, which is non-fraudulent transaction, and class 1 will denote the fraudulent transactions. Right, so we have around 492 fraudulent transactions and around 284,315 non-fraudulent transactions. So when you see this, you know that our data set is highly unbalanced. Highly unbalanced means that one class has a really small number when compared to the other class, right? There's no balance between the two classes. So here what we're doing is we are sorting the data set by class for stratified sampling. Stratified sampling is a statistical technique for sampling your data set. Now this type of sampling is always good if you have an unbalanced data set. Next, what we're going to do is we're going to perform data pre-processing. Data pre-processing in deep learning mainly has a method known as dropout method. Next, what we're going to do is we're going to drop out the entire time column. We do not need the time of the transaction in order to understand if the transaction was fraudulent or not. Right? So that's why we're getting rid of unnecessary variables. Right? So we're dropping out that variable. So after dropping out the time variable, we are going to assign the first 3000 samples to our new data frame. Right? This DF sample will have our first 3000 samples, and we're going to use those 3000 samples. So here we're just counting the number of class for each of these samples. After that, we're just counting the number of samples for each of the class. Right? We're doing the same thing again, and here we get class 0 has 2508 samples and class 1 has 492 samples. Now this makes the data set quite balanced, right? It's very balanced when compared to our old data set. Next, we'll just randomly shuffle our data set, right, in order to remove any sort of biasness in the data. After that, we'll split our data set into two parts. One is for training and your other data set is for testing, right? This is also known as data splicing. Then we'll be splitting each data frame into feature and label, meaning that your input and your output. You'll be doing this for your training data and for your testing data, right? All you're doing is you're separating your input from your output. Next, we're looking at our training data set, right? We're printing the shape of our training data set. The training data set has around 2,400 observations and 29 variables or 29 features. Similarly, we'll be printing out the size of our test data frame, right? That's exactly what we're doing over here. After that, we'll perform normalization. Right, for this, we'll be using the min-max scaler. So in normalization, we'll basically be scaling all our predictor variables around the same range so that there is no biasness in our prediction. After this, we'll be plotting a function for each of the learning curves. For your training phase and for your testing phase, you'll be plotting a learning curve. Now I'll show you the output of this in a couple of minutes. For now, let's move on to the main part, which is model creation. Right, in this demo, we'll use 3 fully connected layers. We'll also use dropout technique. Now, dropout is a type of regularization technique that is used to avoid any sort of overfitting in a neural network. It is a technique where you select neurons and you drop them during the training phase. We'll be using the ReLU as the activation function, which is a type of activation function just like sigmoid and tanh. So the type of model that we'll be using is the sequential model. Right, sequential is the easiest way to build a model in Keras. Right, we're using the Keras library over here. If you remember, I imported that in the beginning. Right, it allows you to build a model layer by layer. So each layer has weights that correspond to the layer that follows it. After this, you'll use the add function to add the dense layers. Basically, your hidden layers you're going to add over here. So in our model, we'll be adding 2 dense layers or hidden layers, you can say. So here what we're doing is we're adding the first dense layer. Now guys, a dense layer is standard layer type that works for most cases. Right? In a dense layer, all the nodes in the previous layer connect to the nodes in the current layer. So guys, don't get too involved into what exactly is happening here. All I'm doing is I'm creating a sequential model. And what is happening is I'm just assigning the number of inputs for each of the dense layer or for each of the hidden layer. I'm also assigning dropout value. Dropout is basically to prevent overfitting. Overfitting might occur when your model memorizes the training data set. Overfitting basically reduces the accuracy of a model. That's why we're using the dropout method to prevent overfitting. So in the first hidden layer, we have around 200 units, right? We have the activation function ReLU. Then we're adding the second dense layer with again 200 neurons and the ReLU activation function. Kernel initializer is uniform, meaning that it's just sequential and normal. Then we're again adding a dropout layer of 0.5. The dropout value of a network has to be chosen very wisely. Okay, a value that is too low will result in a minimal effect, and a value that is too high will result in underlearning by the network. So 0.5 is a standard dropout value. Now this last layer is our output layer. In the output layer, we'll obviously have only one neuron. We'll have one neuron that will show us the output class, either 0 or 1. 0 will show us non-fraudulent transactions and 1 will denote fraudulent transaction. Right? That's why we have only one neuron over here, and the activation function here is sigmoid, right? Since the number of neurons is only 1. After that, we're printing the model summary. Now, I'll show you the summary and everything. Before that, let's just understand what exactly optimization functions are. We'll understand what this optimization function does. Now, an optimizer takes care of the necessary computations that are used to change the network's weights and bias. So basically, your optimizers will take care of all your computations, such as changing the weight or updating the weight. If you'll remember, I spoke about backpropagation, right, where you'll update the weight and all of that. That is done by using optimizers. Here we're selecting an optimizer known as the ADAM optimizer. So ADAM optimizer is one of the current default optimizers in deep learning. Right? It stands for adaptive moment estimation. We don't have to get into the depth of all of this. Right? All of these are predefined optimizers in our Keras package itself. After this, we're going to fit our model by using the training features. We're also setting 200 epochs, and also there's something known as epochs and batch size. Right? We're setting epochs as 200 and batch size as 500. I'll tell you what exactly this means. Now, batch sizes are basically used so that we don't overfit our model, right? We're going to basically split our data set into 500 batches. So our input will be going in the form of batches, right? And our batch size is 500 inputs per batch, and we'll be going through 200 epochs, meaning that our training will iterate 200 times. This is basically the number of times we're training our model. All right, that's what epoch and batch size is. After that, we're just showing our training history, and we're just printing the accuracy curve for our training phase. We're also going to print our loss curves for our training phase, basically the error curves. And then finally, we have the evaluation. Here we'll be testing our model by using our testing data set. Then we're finally printing the accuracy on our testing data set. After that, we're just going to plot a heat map, which I'll be showing y'all. Let me just show you the output. So guys, in this entire line of code, all we're doing is we're printing an accuracy plot, right? Basically, we're printing a heat map. I'll show you what the heat map looks like. This is just to check the accuracy. We're comparing all the correctly predicted values to our incorrectly predicted values. So this is our training history. Here, blue stands for our training phase, and this is our validation or our prediction stage. That was our training curve, and this is our loss curve. Now, when you compare it to the actual validation stage, it's quite similar, right? Meaning that our model is doing pretty well. So guys, this is the heat map that I was talking about. This is basically going to give us the class for each of our predictions, right? It basically plots the classes that we correctly predicted, right? Basically for each data point, it's just going to tell us whether we predicted it correctly or not. It's sort of a confusion matrix in the form of a heat map. So guys, these are all our epochs, basically the 200 iterations that we went through, right? This is the 50th iteration, is showing us our loss, it's showing us our accuracy as well. Right here we have 88%, 90%, 92%. Now, if you carefully look at the epoch accuracy values, you see that as we train our model even more, our accuracy keeps increasing. Initially, our accuracy was around 83, right? At epoch number 15, our accuracy was around 83%. But as we kept training our model a little bit more, our accuracy kept increasing. We have 90, we have 91, 94, 95, 96, and so on. Right? So basically, the more you train your model, the better it's going to be. So guys, this was our entire demo. Now, in the end, I'm printing out the false positive rate and the false negative rate. Right? All of this basically denotes how many of the data points was I correctly able to predict as fraudulent and how many did I predict wrongly. That's all the false negative and the false positive rate denotes. So guys, this was the entire demo on deep learning. Now, if you have any doubts regarding the deep learning demo, please mention them in the comment section and I will solve your queries. Right now, let's look at our last topic for the day, which is natural language processing. Now, before we understand what is natural language processing, let's understand the need for natural language processing and a process known as text mining. Text mining and natural language processing are heavily correlated, right? I'll talk about both of these in the upcoming slides. For now, let me tell you why we need natural language processing or text mining. So, guys, the amount of data that we're generating these days is unbelievable. It is a known fact that we are creating 2.5 quintillion bytes of data every day, and this number is only going to grow. With the evolution of communication through social media, we generate tons and tons of data, right? The numbers are on your screen. So basically, we post around 1.7 million pictures on Instagram per minute, right? I'm talking about posts per minute. All of these numbers are per minute values. These are the amount of tweets, 347,000 tweets per minute, right? This is a lot of data. We're generating data while we're watching YouTube videos, when we're sending emails, when we are chatting, and all of that, right? Even the IoT devices at our house, right? We have Alexa, all of this is generating a lot of data. A single click on your phone is generating a lot of data. Now, not only that, out of all the data that we generate, only 21% of the data is structured and well formatted, right? The remaining of the data is unstructured. And the major sources of unstructured data include text messages from WhatsApp, Facebook likes, comments on Instagram, the bulk emails, and all of this, right? All of this accounts for the unstructured data that we have today. Now, the data we generate is used to grow a business. So, by analyzing and mining the data, we can add more value to a business. This is exactly what natural language processing and text mining is all about. Text mining and NLP is a subset of artificial intelligence wherein we try and understand the natural language text that we get from text messages and so on in order to derive useful insights and grow businesses by using these insights. So, what exactly is text mining? Text mining is a process of deriving meaningful insights or information from natural language text. So all the data that we generate through text messages, emails, and documents are written in natural language text, right? And we're going to use text mining and natural language processing to draw useful insights or patterns from such data in order to grow a business. Now let's understand where exactly do we make use of natural language processing and text mining. Now, have you ever noticed that if you start typing a word on Google, you immediately get suggestions, right? This feature is known as autocomplete. It will basically suggest the rest of the word to you. We also have something known as spam detection, right? Here's an example of how Google recognizes this misspelling Netflix and shows results for the keyword that matches your misspelling. Let me show you a couple of more examples. We also have predictive typing and spell checkers and features like autocorrect, email classification. So, predictive typing and spell checkers, all of these are applications of natural language processing. All of this basically involves processing the natural language that we use and deriving some useful information from it, right? Or running businesses from it. Netflix uses natural language processing in a really good fashioned way, right? It basically studies the reviews that customer gives for a particular movie and it tries to figure out if that movie is good or bad depending on the review. So Netflix actually uses NLP in a very interesting manner. It tries to understand the type of movies that a person likes by the way a person has rated the movie or by the way the person has reviewed a movie. So by understanding what type of review a person is giving to a movie, Netflix will recommend more movies that you like. That's how important NLP has become. Now let's look at what exactly NLP is. NLP, which also stands for Natural Language Processing, is a part of computer science and artificial intelligence, which deals with human language. Right? It's basically the process of processing natural language in order to derive some useful information from it. For those of you who have studied natural language processing or have heard of natural language processing, there is a huge confusion between text mining and natural language processing. So text mining is the process of deriving high quality information from text. But the overall goal is to turn the text into data for analysis by using natural language processing. So basically, text mining is implemented by using natural language processing techniques. Right? There are various techniques in natural language processing that can help us perform text mining. That's how text mining and natural language processing are related. Natural language processing is the techniques that are used to solve the problem of text mining, text analysis, and all of that. Let's look at a couple more applications. Sentimental analysis is one of the major applications of natural language processing. You see, Twitter performs sentimental analysis, Facebook, Google, all of these perform sentimental analysis. Sentimental analysis is mainly used to analyze social media content that can help us determine the public opinion on a certain topic. And then we have chatbots. Now, chatbots use natural language processing to convert human language into desirable actions. We also have machine translation. NLP is used in machine translation by studying the morphological analysis of each word and translating it to another language. Advertisement matching is also done using NLP in order to recommend ads based on your history, right? These are few of the applications of NLP. Now, let me tell you the basic terminologies under natural language processing. So, tokenization is the most basic step in natural language processing. Tokenization means breaking down the data into smaller chunks or tokens so that they can be easily analyzed. So, the first step is you'll break a complex sentence into words. Then you'll understand the importance of each of the word with respect to that sentence in order to produce a structural description on an input sentence. So, for example, take this sentence. How would I perform tokenizations on this sentence? Let's say that tokens are simple is a sentence and I want to perform tokenization on this sentence. This is what I'm going to do. I'm going to split the sentence into different words. I'm going to understand each word with respect to that sentence, right? This is done to simplify operations in natural language processing, right? It's always simpler to analyze a single token instead of analyzing an entire sentence. Then we have something known as stemming. Now look at this example. Right here we have words such as detection, detecting, detected, and detections. We all know that the root word for all of these words is detect. So stemming algorithm basically does that. It works by cutting off the end or the beginning of the word and taking into account a list of common prefixes and suffixes that can be found in an inflected word. Stemming basically helps us in analyzing a lot of words. We know that detections, detected, and detection basically mean the same thing. So all we're doing is we are going to ease our analysis by removing prefixes and suffixes which do not make sense, right? We just need to understand the morphological analysis of the word, right? So that's why we're randomly cutting the prefixes and suffixes in such a way that we only get the important part of the word. This is called stemming. Now, this cutting of words can be successful in some occasions, but not always. That is why we say that stemming approach has a few limitations. In order to get over these limitations, we have a process known as lemmatization, right? Lemmatization, on the other hand, takes into consideration the morphological analysis of the words. It does not randomly cut the word in the beginning and the ending. It understands what the word means and only then it cuts the word. For example, let's consider the word recap. If we perform stemming on the word recap, we'll get cap, right? The output will be cap. But cap and recap do not have the same meaning, do they? They have absolutely different meanings. That's why stemming is sometimes not considered to be the right thing to do. But when it comes to lemmatization, it's going to understand the meaning of recap. Only then will it perform any sort of change in the word or it'll cut down the word. So basically, it groups together different inflected forms of a word called lemma. Lemmatization is similar to stemming because it maps several words into one common root, but the output of a lemmatization process is always a proper word. An example of lemmatization is to map gone, going, and went into go. Gone, going, went, all of them mean go. So basically, by lemmatization, you can just output the words as go. That is what lemmatization is. Next, we have something known as stop words, right? Stop words are basically a set of commonly used words in any language, right? Not just English, any language. The reason why stop words are critical to many applications is that if we remove the words that are very commonly used in a given language, we can finally focus on the important words. For example, in the context of, let's say you open up Google and you look for strawberry milkshake recipe. Instead of typing strawberry milkshake recipe, let's say you type how to make strawberry milkshake. Now here what Google will do is it will find results for how to and make. Instead, if you just type strawberry milkshake recipe, you will get the most desired output. That's why it's always considered a good practice in natural language processing to get rid of stop words, right? Stop words will just increase our computation and it'll just add additional work to us. They are not very helpful when we are analyzing important documents, right? We need to focus on the important keywords in the documents instead of all of these commonly used words. Example of stop words include the, how, when, why, not, yes, no. All of these are stop words, right? So in order to better analyze our data, we need to get rid of stop words. Now, the last terminology I'm going to discuss is document term matrix. Now, it is important to create something known as the document term matrix in natural language processing. A DTM or a document term matrix is basically a matrix that shows the frequency of words in a particular document. Let's say that we're trying to understand if the sentence "this is fun" is available in one of my documents. So if it is there in my document 1, I'm going to put a 1 corresponding to each of the words that is available in my document. For example, in document 2, I have "this is," but I do not have the word "fun." Similarly, in document 4, I have the word "this," but I do not have the word "is" and "fun." So basically, a document term matrix is like the frequency matrix of a document. So during text analysis, you always begin by building a document term matrix. Right here, you try to understand which words frequently occur and which words are important and not important in the document. So guys, these were a couple of terminologies in natural language processing, and with this, we come to the end of today's session, right? We discuss a couple of topics here. We discuss machine learning, deep learning, natural language processing. We also saw the various Python packages that are needed in order to understand artificial intelligence with Python. So if any of you have doubts regarding today's session, please let me know in the comment section. Apart from that, I'll be leaving all the important links in the description box. So guys, that's all for today's session. I hope all of you enjoyed it, and make sure you subscribe to our channel to stay updated about recent technologies. Until next time, happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!